Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos. Thanks for your help. Also, remember to sign up via the link in the description to get all of the lab files for this course, so you can try it out yourself in Packet Tracer. If you want more labs like these, I highly recommend picking up Boson's ExSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even better, and it includes all of these guided labs to not only help you get hands-on practice configuring and troubleshooting, but also deepen your understanding of the exam topics. I used it myself when studying for my certifications, so I feel confident about recommending it to all of you. If you want to get your own copy of ExSim, please follow the link in the video description. In this video, we'll practice some basic EIGRP configurations. The configuration of EIGRP itself isn't part of the exam, but I want to use this video to introduce some aspects of EIGRP that might come up on the exam, specifically EIGRP Metric, path selection, and Unequal-Cost load balancing. My advice is to try to remember the extra topics I introduce in this video, but don't worry about remembering all of the EIGRP specific commands. Actually, this video will be half lab and half lecture, since I want to introduce those other topics. This network here is EIGRP AS100, so we'll have to make sure we configure each of these routers in AS100, or they won't become EIGRP neighbors, and therefore won't exchange route information. In this network, the link between R1 and R2 is a gigabit Ethernet connection, but the other connections between routers are fast Ethernet. Step 1 is to configure the appropriate host names and IP addresses on each device, and also enable the router interfaces. Instead of pre-configuring everything, I decided to give you some extra practice with the basics. To save time in this video, I did pre-configure everything before recording, but in the file you download, you'll have to configure the IP addresses and such yourself. So let's move straight to step 2. Configure a loopback interface on each router. I only briefly mentioned these in the last video when talking about router IDs, and I'll talk more about them in the OSPF videos coming up next, but I wanted to give a little preview here. I'll hop on R1 and configure its loopback interface. Enable. First, let's check R1's interfaces. Show IP interface brief. So you can see the interfaces, which I pre-configured here, but no loopback interface yet. So let's make one. Enter global config mode, conf-t, interface, and let's use the question mark. Here you can see the loopback option. So type in loopback, or as a shortcut, just the letter L works too. Then let's use the question mark again. As you can see, the numerical range you can use for the loopback interface is quite large. I'm not sure what the maximum number of loopback interfaces you can create on a router is, but it probably depends on the type of router. Anyway, I'll just make this loopback 0. As soon as you enter the command, you get a notice saying the interface has come up. Now you can configure the IP address just like on a physical interface. IP address 1.1.1.1, 255.255.255.255. It's common to use a /32 mask for loopback addresses. I won't talk in depth about loopback interfaces in this video. Just know that a loopback interface is a virtual interface in the router. Now let's check the interfaces here once more. Do show IP interface brief. Now you can see the loopback 0 interface and the IP address we configured. Notice it's up. A loopback interface is always up, unless you manually disable it with the shutdown command. Now I'll go through the other routers and configure their loopback interfaces. Next up, R2. Enable, conf-t, interface L0. As you can see, you can just type L followed by the interface number to configure a loopback interface. IP address 2.2.2.2, 255.255.255.255. Next, let's configure R3. Enable, conf-t, interface L0. IP address 3.3.3.3, 255.255.255.255. And finally, R4. Enable COMPLETE interface L0, IP address 4.4.4.4, 255.255.255.255. Okay, that's all for step 2. Next up, let's configure EIGRP on each router. Since I'm on R4 already, I'll start here. You can enter EIGRP configuration mode directly from interface configuration mode. There's no need to go back to global config mode. Router EIGRP, and for EIGRP we have to enter the AS, Autonomous System Number. This number must match for 2 routers to become EIGRP neighbors. In this lab, I'm using an AS number of 100. From here, let's enable EIGRP on all interfaces. Actually, let me show you a little shortcut. This is not recommended in real networks, because you should be more precise about which interfaces you want to enable EIGRP on. But you can enable EIGRP on all interfaces at once with this command: network o.o.o.o 255.255.255.255. Remember, the network command uses a wildcard mask. So this is like a subnet mask of o.o.o.o, meaning a /0 prefix length. So all IP addresses are in the o.o.o.o/o range. Therefore, EIGRP is activated on all interfaces. Once again, not recommended in real networks, but a simple trick for labs. Next, we are instructed to disable auto-summary. The routers I used in the lecture video had auto-summary disabled by default. However, these routers have it enabled by default, so we should disable it. Let me show you it's activated. Do show IP protocols. It says right here, automatic network summarization is in effect. So let's turn that off. No auto-summary. And let's check once more. Do show IP protocols. Automatic network summarization is not in effect. That's better. Next up, we are told to configure passive interfaces where appropriate, including loopback interfaces. So I said in the lecture video that we should make interfaces like G00, not connected to any EIGRP neighbors, a passive interface. However, it's a good idea to do it on loopback interfaces also. Why? Well, the router will treat the loopback interface like any other interface and try to send EIGRP messages out of it, even though the loopback interface isn't connected to any device. It's just a waste of resources on the router, so we should make it a passive interface. Let's do that. Passive interface G00, passive interface L0. And let's check. Do show IP protocols. Now Gigabit Ethernet 00 and Loopback 0 are listed as passive interfaces. Okay, that's all of the configuration on R4. Next, I'll do R3. Directly from interface config mode, let's go into EIGRP config mode. Router EIGRP 100. Again, make sure that AS number matches with the other routers. Here on R3, I'll be a little more responsible and use the exact prefix on each interface to enable EIGRP. Network 10.0.13.0, o.o.o.3. That's a /30 prefix length written as a wildcard mask. Network 10.0.34.0, o.o.o.3. Don't forget the loopback interface. We want to advertise R3's loopback address to the other routers. Network 3.3.3.3, o.o.o.o. That's a /32 prefix length written as a wildcard mask. Next, disable auto-summary. No auto-summary. Finally, make loopback 0 a passive interface. Passive interface L0. Let's check the configurations. Do show IP protocols. Auto-summary is disabled. These are the network commands I configured, and loopback 0 is a passive interface. Looks good. Next up, I'll do basically the same configurations on R2. Router EIGRP 100. Network 10.0.12.0, o.o.o.3. Network 10.0.24.0, o.o.o.3. Network 2.2.2.2, o.o.o.o. No auto-summary. Passive interface L0. That's it. I'll quickly check that everything is okay. Do show IP protocols. Auto summary is disabled, the network commands are correct, and loopback 0 is a passive interface. Finally, I'll go on R1 and do the same configurations, but we'll spend some more time here and get a little more in-depth about how EIGRP works. Router EIGRP 100. Network 10.0.12.0, 0.0.0.3. Network 10.0.13.0, 0.0.0.3. Notice how quickly EIGRP forms adjacencies with its neighbors. It's basically instant. Network 1.1.1.1, 0.0.0.0. No auto summary. Passive interface L0. Okay, first up I'll check do show IP protocols like the others. Auto summary is disabled. I've configured the correct network prefixes. Loopback 0 is a passive interface. And you can also see R1's EIGRP neighbors down here, meaning EIGRP was successfully enabled on its interfaces. Let's check a better command to view the EIGRP neighbors. Do show IP EIGRP neighbors. OSPF has basically the same command to view neighbors, so remember this one. You can see R1's two neighbors, which interface they are connected to, and some other information that you don't need to worry about now. Let's also check if R1 is receiving the correct EIGRP routes. Do show IP route. And you can actually filter the command to view only EIGRP routes in the routing table by adding EIGRP on the end like this. You can also do commands like this. Do show IP route connected, which shows connected routes. If we configured static routes, you could see them with show IP route static, etc. But this time, let's view the EIGRP routes. Do show IP route EIGRP. Notice the D that indicates EIGRP routes. So R1 has routes to the loopback interfaces of R2, R3, and R4. Also routes to the 10.0.24.0 subnet between R2 and R4, the 10.0.34.0 subnet between R3 and R4, and 192.168.4.0/24, R4's internal network. Perfect. Notice EIGRP's metric numbers. For example, 156,416 to R4's loopback interface. Fortunately, when we move to OSPF, you'll see the numbers are much smaller and easier to calculate. Okay, now one last command. This one is important to understand step 4. Do show IP EIGRP topology. Here you can see more detailed information about the EIGRP routes R1 has received, not just the ones in the routing table. For example, here are two routes to 192.168.4.0/24, although only one is entered in the routing table. That's the route via R2, since it has a lower metric value because of the gigabit Ethernet link. Okay, it's time to go into lecture mode to explain some things about EIGRP. First off, let me explain a little bit more about EIGRP Metric, even though I've mentioned it briefly a few times. By default, EIGRP uses bandwidth and delay to calculate the metric of a route. This is the formula used to calculate metric. It looks quite complicated, but there's no need to memorize it. Notice the K values, K1, K2, K3, K4, and K5 in the formula. The default K values are K1 equals 1, K2 equals 0, K3 equals 1, K4 equals 0, and K5 equals 0. K1 is multiplied by bandwidth, and K3 is multiplied by delay. Since you don't have to worry about memorizing this formula or actually calculating EIGRP metric yourself, you can just think of EIGRP metric like this. Metric equals bandwidth plus delay. But there's something else you should know. Let me demonstrate here. It's not simply bandwidth plus delay, but rather bandwidth of the slowest link in the path to the destination, plus the delay of all links in the path to the destination. For example, let's say R1 wants to send traffic to R4's LAN, 192.168.4.0/24. The route via R2 is the best. So the bandwidth of the slowest link, that's this one here, is added to the delay of all links, these three, and then you get the total metric value of the route. By the way, the routers don't actually send ping messages to measure the delay of each link. the delay value, is actually a default value based on the interface bandwidth. So what should you remember about EIGRP metric for the test? Remember that it's calculated by adding the bandwidth of the slowest link to the delay of all links. Let's move on. Now let's cover some important EIGRP terminology. Feasible distance means this router's metric value to the route's destination. From R1's perspective, trying to reach 192.168.4.0/24, that means the metric of the whole route, from R1 to R2, then R2 to R4, then for R4 to send the traffic out of its own interface. But there is another term you should know: reported distance, which is also known as advertised distance. This is the neighbor's metric value to reach the destination. So for this route, the neighbor is R2. The reported distance is R2's metric to the destination. Note that these terms are not related to the concept of administrative distance. EIGRP uses the term distance, but this is the metric used to compare EIGRP routes, not the administrative distance, which is used to compare routes from different routing protocols. Let's take a look at the real costs in Packet Tracer. Here's the output of the show IP EIGRP topology command, just for the route to the 192.168.4.0/24 network. The number on the left is R1's metric, the feasible distance. The number on the right is R1's neighbor, R2's metric, the reported distance. How about the route below it via R3? This is the feasible distance, R1's total metric to reach the destination. This is the reported distance, R1's neighbor, R3's metric to reach the destination. Why is it important to know both of these terms? You need to know them to understand the next two terms I'm going to introduce. Here are the next two terms. Successor is the term for the route with the lowest metric to the destination, so it's the best route. In this case, which route to 192.168.4.0/24 is the successor? It's the route via R2, because it has the lower metric. It's the best route. Next term. A feasible successor is an alternate route to the destination. It's not the best route, but it must meet the feasibility condition. Okay, pay attention here. What is the feasibility condition that must be met? A route is considered a feasible successor if its reported distance is lower than the successor route's feasible distance. So, does the route via R3 meet this feasibility condition? Its reported distance is 28,416. The successor route via R2's feasible distance is 28,672. 28,416 is less than 28,672, so the route via R3 is a feasible successor. Why does EIGRP have this system of feasible successors? It's a kind of loop prevention. If a route meets the feasibility requirement, it is guaranteed not to be a looped route. I'm not going to spend time explaining that in depth, but remember that this is a loop prevention mechanism. With that knowledge, let me now explain how EIGRP does unequal cost load balancing, a unique feature of EIGRP, because other routing protocols only perform load balancing if each route's metric is equal. So here is some output from the show IP protocols command. Down here it says EIGRP maximum metric variance 1. This is the default value, 1. With the variance of 1, only equal cost multipath, ECMP load balancing will be performed. This means a route's feasible distance must be equal to the successor route to be chosen for load balancing. Actually, if another route's FD is equal to the successor route's FD, that route is a successor too. There can be multiple successors. So with the default settings, EIGRP doesn't do unequal cost load balancing. For example, these are R1's routes to 192.168.4.0/24. This is the successor route's FD, and this is the feasible successors. It's higher, so it can't be used to load balance. So from EIGRP configuration mode, I used the variance command and set it to 2. What does that mean? Well, it's basically a multiplier. Variance 2 means that feasible successor routes with an FD up to 2 times the successor route's FD can be used to load balance. Let me explain with our example. Here are our routes. The successor's FD is 28,672, but I just configured a variance of 2, so we can double that. 28,672 times 2 equals 57,344. The feasible successor's FD is 30,976. 30,976 is less than 57,344, so the route via R3 can now be used for load balancing. I'll show you in the next slide that it has now been entered in the routing table of R1. But let me emphasize one thing. EIGRP will only perform unequal cost load balancing over feasible successor routes. If a route doesn't meet the feasibility requirement, it will never be selected for load balancing, regardless of the variance. This is because the feasibility requirement is an important loop prevention mechanism, so the router will never ignore it and put a non-feasible route in the routing table. Here is that route to 192.168.4.0/24 as shown in R1's route table. Notice that even though the two routes have different metric values, R1 now inserts both into the routing table. However, R1 will send slightly more traffic via R2 than R3, because R2's path has a lower metric. It's a faster path. Before finishing up, let me review those 4 terms. A route's feasible distance is this router's metric value to the route's destination. A route's reported distance is the neighbor router's metric value to the destination. Remember that this is also called advertised distance. A successor route is the route with the lowest metric to the destination, the best route. However, there can be multiple successors if they have the same metric. EIGRP will do ECMP load balancing. A feasible successor route is an alternate route to the destination, which meets the feasibility condition. And finally, that feasibility condition is this. A route is considered a feasible successor if its reported distance is lower than the successor route's feasible distance. Now, at this point, I usually show you an extra lab in Boson ExSim. However, since we just did this mini lecture, and I found a really relevant question in ExSim, let's do another question in ExSim instead. Okay, for today's Boson ExSim practice question, we have a question that's really relevant to what we just studied. So click on Launch Simulator, and here it is. Select the following EIGRP terms from the left and drag them to the right, placing them over the corresponding definitions. So these are the 4 terms we just looked at. Advertised distance, which is reported distance, feasible distance, feasible successor, and successor. And then the 4 definitions. So they give slightly different definitions than what I gave you, so you'll have to think about this a little bit. The best metric along a path, the best path to a destination network, a backup path that is guaranteed to be loop-free, and the metric that the next hop router, the neighbor router, has calculated. So pause the video here to match those terms with the definitions. Okay, hopefully you got the answer. So 2 of these terms, the ones with distance in the name, refer to a kind of metric, a metric value. And these 2, successor and feasible successor, refer to a kind of route in EIGRP. So for example, successor is the best route to a given destination. Or as Boson puts it, the best path to a destination network. That is the successor route. And feasible successor is the other kind of path. A backup path that is guaranteed to be loop-free. That is an EIGRP feasible successor. Okay, now we have the 2 kinds of metric. One of them is the best metric along a path, and the other is the metric that the next hop router has calculated. So the metric that the next hop router has calculated is the advertised distance. It is the distance, the metric, that the neighbor router advertises to the local router, this router. Then finally, the feasible distance is the best metric along a path. So click on Done, then Show Answer. And I was correct. So this is Boson's explanation here. And also it has a reference to some Cisco documentation, Introduction to EIGRP. This Cisco documentation is also a great resource, by the way. Okay, so if you want to get a copy of Boson ExSim, please follow the link in the description. I highly recommend you do. Actually, I'm studying for my CCNA now. I already have my CCNA, but I want to take the new exam to help improve my course. So I'm using Boson ExSim to help guide my studies, and it's really helpful. So once again, if you want to get a copy, please follow the link in the video description. Before finishing today's video, I want to thank my JCNP level channel members. Thank you to Ed, Tillman, Value, Magrathia, Justin, John, Funny Dart, Scott, Hassan, Gerard, TB, Vikram, Joyce, Marek, Velvijakum, C Mode, Johan, Mark, Miguel, Yusuf, CD, Boson Software, the makers of ExSim, Charlesetta, Devin, Alexander, Lito, Mike, Jonathan, and Vance. Sorry if I pronounced your name incorrectly, but thank you so much for your support. One of you is still displaying as channel failed to load. If this is you, please let me know and I'll see if YouTube can fix it. This is the list of JCNP level members at the time of recording, by the way, July 12th, 2020. If you signed up recently and your name isn't on here, don't worry. You'll be in future videos. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.